Well, based upon my definition here, what would the units of heat be? Or what is a unit of heat?
Joule.
Yeah, joules. However, because things are established long before standards are, or habits are established, you will often find, if you look up various bits of what are called latent heats, they don't always have it in terms of joules, they have it instead in terms of calories. And so it's just a different unit, and so 1 calorie is equal to 4.184 joules.
Is that at all related to food calories?
It is related, but it is not the same. Because of course, you don't want to use the same word to mean the same thing in two different situations. All right, so then we get into food calories. The food calorie with a capital C is equal to 1,000 calories with a lowercase c, or 1 kilocalorie. Let's connect some things here. Because we have this heat, we have change in temperature, there's a relationship between the two. Now, obviously, the more energy you put into it, the greater the temperature. So there is a direct relationship between those two. And I left some space here for the missing things. What also matters is, since temperature actually is related to the average kinetic energy of the particles, that means the more particles I have, the more energy gets sort of distributed out. If I put 10 joules of energy into a system, the more particles I have, the lower the change in temperature. So it does sort of get spread out. And so another thing that is of significance here is the mass. You could connect it to density and volume, but they have it in terms of mass. And then this right here, known as the specific heat. And that is dependent upon the object itself. So just as an example here, the specific heat of aluminum is 0.215 calories per gram degrees Celsius. What this means is that if I put 0.215 calories into 1 gram of aluminum, it's going to raise the temperature by 1 degree Celsius. So let's do a little conversion, just so, because you might see it's written differently in different places. So the specific heat of aluminum, 0.215 calories per gram degrees Celsius. Well, let's figure out how many joules per gram degree Celsius it is. Well, I got a little conversion factor right down there. So I multiply times 4.184 joules per calorie. My calories cancel out. And so my math problem is 0.215 times 4.184.
0.899.
Joules per gram degrees Celsius. Since we're moving over to SI units here, so the international standard, let's do kilograms instead of grams. So how many grams in a kilogram?
1,000.
So we would multiply times 1,000 grams per kilogram. My grams are going to cancel out. So this math I can do in my head. So it's 899 joules per kilogram degrees Celsius. And since Kelvin is the international standard, how many joules per kilogram Kelvin would it be? So let's go back to the conversion between degrees Celsius and Kelvin. So 0 degrees Celsius is 273.15 Kelvin. 20 degrees Celsius, 293.15 Kelvin. In other words, all I'm doing is I take my degrees Celsius and I add 273.15, often just shortened to 273, and that gets me Kelvin. If I'm converting this into joules over kilogram Kelvin, what's the number here? It's simpler than you think.
3.29?
No. I guess you divide it by 273.15.
Yes.
And the trouble is that you're not multiplying by 273.15 to go from one to the other. You're adding.
Oh.
And it will say if you're pulling out the calculator, you're thinking about it wrong.
Would you just add that number?
No,
Is it still the same?
it is What we care about is the change in temperature. 1 degree Celsius in a change is the same as 1 Kelvin in a change of temperature. 0 degrees Celsius to 1 degree Celsius, the change in temperature is 1 degree Celsius. If we converted this into Kelvin, this would be, I'm just going to drop the 0.15 right now. This is 273 Kelvin going to 274 Kelvin. My change in temperature is just 1 Kelvin. So the change is still the same, and so that's why when you're dealing with specific heat, if you see degrees Celsius on the bottom, you can just as easily just put a K there.